In this video, we're going to be able to find the measures of some angles based on their relationship to each other. And so at the end, you're going to be able to use those relationships to find out the measure of certain angles. So we're going to be using some parallel lines cut by a transversal. So let's go ahead and go through the vocabulary. I hope you're using a pencil for your notes. Corresponding angles are two angles that, if they are on the same side of the transversal, then they are congruent. So first of all, we have to make sure that the lines that they are on are parallel lines. So pretty much all of these four sets of angles are going to be on parallel lines. So again, when you're looking at a diagram, if the little arrow is on those lines, then you know that they're parallel. And then of course the line that cuts through them or intersects with them is called the transversal. Corresponding angles are congruent if the lines that they're on are parallel. So for instance, in this diagram that I have here, this angle that the dot is in and this angle that the dot is in are called corresponding because they're in the same position. So we can abbreviate the corresponding angles with just CA, and then let's remember that they have to have the same position. Alright, the next type of angle pair that we're going to be looking at is the alternate interior angles. So the alternate interior angles are the ones that are on the opposite sides of the transversal, but inside the parallel lines. So that's what we mean by interior. Those angles are congruent as long as they have that relationship, and again, they have to be on parallel lines. The next type of angle pair is the alternate exterior angle pair, and if these two are going to be on parallel lines also, and then if those parallel lines are cut by a transversal, we're going to have alternate exterior angles, the ones that I just put the X in, and we can abbreviate these AEA. And they have to be outside the parallel lines and on opposite sides of the transversal. And let's go back and abbreviate this one with AIA. And it is a lot to write out the entire angle name, so we'll just use those three-letter, or in this case, two-letter abbreviation. Now the only one that's just a little bit different is the consecutive interior angle theorem, and that's where if two parallel lines still have to be parallel, are cut by a transversal, then the pairs of consecutive interior angles are supplementary. And remember, that just means that they add up to 180. So of all four of these, just this one is the one that has supplementary kind of relationship. So let me just redraw this picture a little bit. So if these are parallel and cut by a transversal, then the angles that are inside and on the same side, these two angles right here, those equal 180 degrees. So same side of the transversal, inside the parallel lines. Let's go ahead and take a look at the first example that we have, identifying congruent angles. So it says here the measure of three of the numbered angles is 56. So we see this one here is 56. Remember, that's an acute number. And we want to identify the other three angles that are also 56 and then tell why, or which type of angle they are compared to the one that we just looked at. So for the first one here, we see that it's 56 degrees. So one that's the closest to it that I would identify is this one here. So angle 3, because it's vertical, and remember vertical angles are congruent, it's vertical to the angle marked 56 degrees. Oops, 56 degrees. Okay, and then the next one that I see that would be something that I can relate to angle 3 is this one. Remember, these are inside the parallel lines, 3 and 5 are, and they're on opposite sides of the transversal. So angle 5, because it's alternate interior angles with angle 3. Okay, so make sure that you're stating the angle pair and also identifying which other angle it's a pair with. so you don't want to cut off your description by forgetting to name the angle. Okay, then the last one here is going to be angle 7. Now there's a couple different things that you could say. You could say that angle 7 relates to this angle here because it's AEA, or you could say that it's corresponding with angle 3, or you could say that it's vertical with angle 5. So each of you might see this just a little bit differently. I think the vertical one is probably the easiest one to see, but because we're looking at all these angle pairs, I'd like to include a different answer here. So I'm going to say that angle 7 is 56 degrees because it is AEA with the angle marked 56 degrees. We don't have a number or a name for that angle, so I just have to say angle marked 56 degrees. Could you have said the other two things that I mentioned? Of course. You could have said that it was corresponding with angle 3. You could have said that it's vertical to angle 5 as well. So for the practice section here, I'd like you to find the other three angles that are 65 degrees. So if angle 2 is 65, which other angles are 65? Remember, there's always an acute and always an obtuse angle in these intersections. And then the next thing you're going to want to do is find out which other angles are 115, since angle 5 is 115. Just remember to make sure you tell why, and make sure that you mention another angle with your answer. All right, hopefully you were successful with those practice problems. The example 2 is going to have us use the properties of parallel lines to find the value of x. Because we know the relationship between angles now, we can set up different equations and solve for x. So in these, it says to name the theorem and or definition that allow you a way to solve the problem, and then also find the value of x. So in this case, this 53-degree angle, remember that there are three other angles here that are 53. This angle is 53, this angle is 53, and this angle is 53. So even though the two angles that initially you see, this one here and the 53-degree angle, really don't have a relationship at all, I can say that this angle here is 53, which creates a situation where I have a linear pair. And remember, the linear pair is going to equal 180 degrees. So now, really I can just say that these angles that we were given are supplementary, because initially they weren't really anything that we could name as a angle pair, but they do add up to 180. So I'm going to say 53 plus 5x plus 2 equals 180. Okay, and then I'm going to combine the things that I can combine because they're the same. So 55 plus 5x equals 180. And I'm going to subtract 55 on both sides, which creates a situation where I have 5x equals 125. Dividing by 5, I have x equals 25. All right, and if I wanted to check, I could just plug that back into this expression here, the 5x plus 2, and make sure that that adds up with the 53 to equal 180. All right, so let's take a look at the next problem over here. What kind of angles do we have? Well, this is an acute angle, this is an acute angle, so they are congruent to each other, and so we can set them equal to each other, but we also have to state what kind of angle pair they are. Well, it looks like this 55 is outside of the parallel lines. This one is outside of the parallel lines as well, and they are on opposite sides of the transversal. So we would call those angles AEA, alternate exterior angles. And then I'm going to set up an equation so that I can say x minus 8 equals 55. Remember, they're both acute angles. And we're going to add 8 to both sides. And that's it. X is going to be 63 degrees. All right, so that is the way that we will show our work and also identify what kind of angle pairs these are. If you would please try these on your own problems, make sure that you're identifying the type of angles they are, setting up the problem, showing all of the work to solve for x. So again, we're using algebra and geometry. If you want to take a look, please, right now at numbers 5 and 8. Okay, these are the ones that are a little bit different. Don't confuse yourself. Remember that this angle down here is 60 degrees, this angle right here is 60 degrees, this angle right here is 60 degrees. So there's a couple different, oops, that's not the one that's 60 degrees. Sorry about that. This one is 60 degrees here. So you'll have to find a way to solve this one, but just be careful about it. And then you also want to take a look at number 8 and remember that this one is 103, this one is 103, and this one is 103. Okay, so be careful when you're doing those. I just wanted to give you a couple hints there. Write down any questions that you have, things that seem confusing from this lesson, and I'll see you tomorrow.